Whenever we run a long VBA macro, like exporting multiple files or looping through thousands of rows, Excel just freezes, right? And most people think, oh no, Excel has crashed. That's where a progress bar really helps. It shows that something is happening in the background. Excel is busy, not dead. In this video, I'm going to show you 6 different ways to create progress bars in Excel using VBA. From the simplest ones to the most creative ones. First, a super lightweight one that sits right inside Excel's status bar using Unicode characters. Second, an in-cell progress bar that uses conditional formatting and gets updated automatically through VBA. Third, the classic UserForm progress bar, the one almost everyone starts with. Fourth, a modern gradient progress bar that looks like a real installer with smooth transitions and clean visuals. Fifth, a spinner style indicator where instead of a bar, a little animation keeps rotating to show activity. And finally, sixth, a walking character animation where a tiny sprite actually walks across the form while your macro runs. And as a bonus, I also added a few ready-to-use sample progress bars that you can directly plug into your projects. I'll talk about those later in the video. So by the end of this video, you'll know exactly which one to use, whether you want something simple, modern, or just plain fun. Alright, let's begin with the lightest one, the Unicode status bar progress bar. So the first type is the lightest one, the status bar progress bar. This one doesn't need any user form or worksheet formatting. It simply uses the status bar at the bottom of Excel, that small area on the left, and displays a moving bar using Unicode block characters. Basically, as our code runs, we'll keep updating that status bar so that it looks like a progress bar filling up. I've already written the code for this one. It's in module A_status bar. Let's go through it together and see what's happening. Launch the Visual Basic Editor by pressing the shortcut key Alt F11. If you are not familiar with the Visual Basic Editor, then I highly recommend watching the video Visual Basic Editor and Introduction. Expand the module to see the modules. Double-click on A_status bar to view the code. Here's the macro. Progress status bar. This is what will show the progress bar in the status bar. Alright, let's break this down. That simply forces us to declare all variables before we use them. It is a good habit. This saves you from typos and weird bugs. We start by setting up 2 variables. Total steps is how many animation steps we want. 4 steps mean a smoother bar. Current step is the counter that will go from 0 to 120 in this demo. This loop runs from start to finish. Each pass updates the bar a little. This calculates progress as a fraction between 0 and 1. 0 means 0%, 1 means 100%. We will use this to build the bar and show the percent. This is the key line. We call build progress bar and pass 2 things. The current progress from 0 to 1 and 30, which is the width of the bar in character blocks. Then we add 2 spaces and show the percentage next to the bar using this. Do events lets Excel update the screen and stay responsive while the loop runs. Pause for seconds 0.1 adds a tiny delay so you can see the animation clearly. In real macros, you usually do not need this pause because your actual work takes time and the bar will move naturally. This is important. It resets the status bar back to normal when your macro finishes. If you forget this, your custom message will stick around. Now, let's check the function that builds the text bar. This function returns a string like this. Progress fraction is from 0 to 1. Total slots is how wide the bar should be. This just keeps the value safely between 0 and 1 in case someone passes a number outside the range. This calculates how many character blocks should be filled at the current progress. Here, we build the 2 parts of the bar. This is the Unicode full block character, which looks like a solid square. This is a light shaded block. We repeat them the required number of times to form the filled and empty sections. Finally, we wrap both parts in square brackets to make the classic progress bar look. This helper pauses for a short time without freezing Excel. We record the current time, then keep looping till the requested seconds pass. We call do events inside the loop, so Excel remains responsive and updates the status bar. This tiny helper just pauses for a few milliseconds. Again, it's only for the demo. In real code, your loop will be doing actual work. Exporting, copying, calculating, so you won't need an artificial pause. Alright, let's run it. Place your cursor inside the procedure and press F5. You can also click on the Run Sub UserForm button. Look at the bottom of Excel. See that bar filling up in real time. That's a progress bar right inside Excel status bar. It stays steady because we are always drawing a fixed width bar of 30 blocks. The percentage keeps updating beside it. And once it's done, the bar disappears because we reset it at the end. That's the cleanest way to give feedback to your users without showing any form or touching the worksheet. Alright, that was our first one, the Unicode status bar progress bar. Now let's move to something more visual. A progress bar directly inside a cell. Alright, next we're going to make the progress a little more visual. Instead of showing it in the status bar, we'll show it right inside a cell. Like a small progress tracker that fills up automatically. And the best part is, Excel already has this feature built in. It's called Data Bars in Conditional Formatting. We'll just control it using VBA. So in this demo, cell D2 will hold the progress value and the green bar inside the cell will fill as the macro runs. Let's head over to Visual Basic Editor. Open the module B underscore in cell. There are two small procedures here. Animate data bar cell and set up a data bar. Let's go through what each of them does. This one is the driver. It picks a target cell, calls the setup sub to apply the data bar formatting and then gradually increases the cell's value from 0 to 1. Every time that cell value changes, Excel automatically redraws the data bar inside it. That's what creates the smooth animation effect. Here, this means we are filling from 0.00 to 1.00 step by step. Pause for seconds. 0.1 simply slows things down so you can see the bar move. In a real macro, you won't need that pause. Your code's execution time itself will make the bar update naturally. Before the animation starts, this line runs once to set up the conditional formatting rule. That's what defines how the data bar should look: color, style, and scaling. This second procedure handles the entire setup. It applies a conditional formatting data bar rule to the cell you pass in. Here, target cell. First, it clears any existing conditional formatting. This ensures every run starts with a clean slate. Then we add a new data bar rule. We grab the last one in the list, the one we just created, and make sure the cell's value is still visible next to the bar. These two lines are very important. They lock the scale between 0 and 1. If you leave it on automatic, Excel will guess the range based on nearby cells. That can make small values like 2% look much larger than they really are. So always fix your minimum and maximum manually. This block is all about styling. Solid fill, no border, no negative bars, and Excel decides the bar direction automatically based on language settings. Here we pick the bar color. Currently it's a soft green, but you can change it to any color you like. Finally, we format the cell as a percentage and reset its value to 0%. So the progress bar always starts empty before the animation begins. Alright, let's run animate data bar cell and see it in action. Now look at that. The bar is filling directly inside the cell and the number is changing automatically as it moves. No shapes, no user form, just pure Excel conditional formatting driven by VBA. When it reaches 1, the bar becomes fully filled. And that's your 100%. This is perfect for dashboards, trackers, or background tasks. You can place it in a status column where each macro updates its progress cell. It's lightweight and doesn't block your workbook. Excel handles all the visuals. So that's our in-cell progress bar. Simple, dynamic, and fully handled by Excel's own conditional formatting. In the next part, we'll take things to the next level and build our first user form progress bar. the classic one that most VBA developers start with. Alright, now let's move on to something that looks like a proper loading window. This is the classic UserForm progress bar. We'll create it directly inside the Visual Basic editor so you can follow along. First, go to Insert and click UserForm. I'll rename this one to FRM Progress Classic. I'm going to resize it so it looks like a small progress window. I will adjust the width for now and adjust the height later. In the properties, I am also setting startup position to center screen, so the form opens in the middle. You can also change the caption of the form. I am setting it to progress. Now I'll add a frame. This is going to act as the track or outline for the progress bar. I'll name this FRA bar. And in the properties, I'm setting border style to single. I'm also setting the caption of the frame to blank so that I get a smooth rectangle. Ensure the special effect is set as flat. Now let's adjust the frame and the form to give it an appropriate look. Inside this frame, we need the actual green bar. For that, I'll add a label and name it LBL bar. I'll set the back color to this green value. Next, I will remove the caption of the label. We will now move the label to the left. And I'm setting the width to 0 for now. We'll increase the width later using code when the progress updates. Now I'll add one more label for the percentage text. I'll name it LBLPCT. Next, I'm changing the font to Tahoma Bold size 12 and I'll set the caption as 100%. I'm doing this so that I can size the label and place it appropriately in the form. I will set it to 0% later. I'm setting the text alignment as center. Once this is done, our label is all set. And now I will change the caption to 0%. We'll increase the width later using code when the progress updates. One last thing, we will change the back style to transparent so that the background of this label does not block the green color of the progress label. That's the basic setup. The green bar will grow inside the frame and the percentage label will stay centered. Now let's add the VBA code behind the form. I'll right click the user form, choose view code and write the procedure. After that, I'll explain exactly what it does. Let's quickly see what this code does and how it works. This subroutine is responsible for updating the progress bar inside our user form. It does not create the bar, it only moves it forward as progress increases. You'll typically call it from a loop that's doing some work and it will visually expand the bar and update the percentage label. So the first thing we do is make sure the input value stays between 0 and 1. That's called clamping. Even if you accidentally pass a number like minus 0.5 or 1.2, this makes sure the progress stays within valid limits, which is from 0% to 100%. FRA bar is the outer frame, which is the container for our progress bar. We take its inside width and multiply it by the current progress fraction. So if progress is 50%, we make the colored bar half the width of the frame. This line resizes the colored bar to the new width. That's what creates the smooth filling effect on the screen. Each time the macro calls this procedure with a higher progress value, the bar grows wider. Next, we update the percentage label. We use the format function to turn the decimal value like 0.5 into a readable percentage. For example, 50%. So as the bar expands, the number beside it also increases in sync. Finally, we call do events. This tells Excel to refresh the form immediately so you can see the change happen in real time. Without this line, Excel would only update the form after the entire macro finishes and you'd miss the animation completely. If you want to make it run in a loop, just call this sub repeatedly from your main macro. Now let's write that macro. Click on Insert and then click on module. Let's call it C_progress classic. I will quickly write the code and then I will explain what I am doing here. Let's go through it line by line. We start by creating an object of our user form FRM progress classic. This form contains the actual bar and the percentage label. We use .showVB modeless, and that's important because it allows the code to keep running while the form stays visible. If we used VB model, Excel would pause until you close the form manually. Next, we set up two variables. Total steps decides how many updates we'll make. The higher this number, the smoother the animation looks. Current step is just the loop counter that runs from 1 to 120. This loop drives the animation. Each time through, we calculate the progress as a fraction. For example, if we are on step 60 of 120, that's 0.5 or 50%. We then pass that fraction into the update progress bar procedure inside the user form. That procedure adjusts the bar width and updates the label accordingly. The small delay pause for seconds 0.05 just slows it down for the demo so you can see it move. As I mentioned earlier, in a real world macro, you won't need this delay. The time your macro takes to run would naturally control the animation speed. Once the loop finishes, we make sure the bar hits 100%, just in case the loop stopped early or rounded down. Then we unload the user form, which clears it from memory and closes the visual window. Okay, it's time to test this progress bar. Place your cursor inside the procedure and press F5. Now watch this. As the loop runs, the bar fills up smoothly and the percentage updates right in the middle. The form closes automatically after it's done. It's clean, simple, and looks professional. That's our classic user form progress bar. This method is solid and works in every Excel version. It's perfect for any macro that takes a bit of time, like cleaning data, generating reports, or looping through large files. Time to give the progress bar a modern look. Same logic as the classic one, but the fill will be a smooth gradient that expands as progress increases. A clean premium bar that looks like a real app loader. The modern progress bar works almost the same way as the classic one we created earlier. The main idea remains the same. The only difference is that instead of using a label to show the progress, we use an image control. This allows us to use a proper gradient which gives the entire progress bar a more polished look. To build this quickly, the easiest approach is to reuse the form we already have. So I'm going to duplicate the classic progress bar form. Right-click the classic form and choose Export. I will save the file on the desktop with the name FRM Progress Model. Now I will go to the desktop. Next, I will right-click the FRM file and open it in Notepad. Inside this file, the only change we need to make is the name. So copy the name of the user form from here. Press Ctrl H to open the Find and Replace window. In the search box, type the name of the classic form, and in the box below it, type the name of the modern form. Once done, I will click the Replace All button. After the text is replaced, I will save the file and close it. Let's go back to VBA. Here I will import this FRM file. Right-click anywhere in the Project Explorer and then click on Import File. I will browse to the desktop, select the FRM file and then click the Open button. This gives us a clean copy of the classic form already renamed and ready for modification. Inside the new form, I do not need the green label anymore, so I will delete it. In the same place, I will add an image control. I will name it IMGFill. Now I will set the border style to none. I will also change the picture size mode to stretch so the gradient scales smoothly. Now we need an image that will act as a gradient. I already have one ready. It is in sheet 2. Let's head over to sheet 2. On sheet 2, there is a shape with a gradient fill applied. You can adjust the colors or create your own gradient here. You can also use an image you downloaded from the internet if you prefer. Now, I will right click the shape and choose Save as Picture. Save it either as a JPG or a BMP file. PNG should be avoided because VBA does not support that format. Now I will go back to the form and assign that saved image to the image control. Once the image is visible, I will place the image control accordingly. Next, we will set the width to 0 because this is what we will animate through VBA as the progress increases. With the design ready, I will right-click the form and open the code window. Inside the code, wherever we used LBL bar earlier, I will replace it with IMG fill. Nothing else needs to change because the logic is the same. Next, I will add a new module and name it D_progress modern. I will copy the code from the classic progress bar module and paste it here. Now I just need to replace the form name FRM Progress Classic with FRM Progress Modern. There is no need to rewrite anything because the behavior remains the same. Let me run the code now. The code worked, but I noticed a small issue. When the image reaches the percentage label, it completely covers the label and we cannot see the updated value anymore. So we need to place the image control behind the percentage label. To fix this, I'll first increase the width of the image control so I can clearly see it. Open the form and select the image control. Now let's increase the width so that it covers the percentage label. With the image control selected, I will right click on it and choose Send Backward. Now the percentage label appears on top and we can see it again. After this, set the width back to 0. There is one more thing I noticed. The label is using a black font. Before the image reaches the label, the text is easy to read. But once the gradient is behind it, the black text blends in and it becomes hard to see. So let us do one thing. We will write a small piece of code that changes the font color to white when the image reaches the area behind the percentage label. I will right click the form, open the code window and quickly type the code. This part of the code checks whether the gradient image has reached the percentage label. If the width of the image is greater than or equal to the left position of the label, that means the label is now sitting on top of the gradient. So in that situation, we switch the font color to white so the text stays visible. If the image has not reached that point yet, we keep the font color black because the background is still light enough to read it clearly. Now let us test the changes we just made. I will open the D_progress modern module and run the procedure from there. You can see how the bar fills smoothly and the gradient gives it a clean and modern look. You can experiment with different gradients, lighter colors, darker colors, anything you prefer. By the way, you can also use this approach in the classic version by replacing the label with an image control and using a solid green picture. And that completes the modern progress bar. It behaves just like the classic one, but the gradient makes it look much more refined. In the next section, we will move to a different type of progress indicator. All the progress bars we have created so far depend on knowing how much progress is left. Sometimes Excel is doing something unpredictable and you have no idea how long it will take. In those situations, a spinning indicator works much better because it simply shows activity. So let us create a simple spinner next. Alright, let us build this spinner step by step. First, we need a new user form. I will quickly add one now. Let's name it FRM Progress Spinner. I will also change the caption to Progress. To make it look cleaner, I am changing the background color to black. A dark background works really well for spinner animations. The border style goes to single, so the form has a simple frame. For startup position, I am choosing center screen, so it always opens in the middle of the screen. Next comes the spinner itself. From the toolbox, I am dragging a label onto the form and placing it near the bottom right. This label will be the spinning character, so I am renaming it to LBL spin. The default caption says label 1, so I am replacing that with a vertical bar. That will be our starting spinner symbol. The font needs to be adjusted because this is what makes the spinner look smooth. Consolas is perfect for this since it is a monospace font and every character has the same spacing. That prevents the spinner from jumping left and right. I'm setting the font to Consolas with a font size 20. Next, I will change the forecolor to white. Let's size the label and place it appropriately. Great! Now we need the message label. This will display a text, something like walking. Let's place another label just below the spinner. I will name it LBLMSG. I will set the caption as walking. The font stays simple around size 10. We will, however, set the forecolor to white. I will also set the back style to transparent. This helps the dark background show through and keeps everything clean. Next, let's tidy things a bit. I will adjust the labels so they sit neatly in the bottom right corner with a small margin around them. Time to test the layout. Press F5 to launch the form. The form looks nice, nothing moves yet, which is fine. The animation will start once we add the code that cycles through the characters. So the design part is done. Now we can add the logic that creates the spinning effect. The idea is simple. We prepare a small list of characters like this, vertical bar, / dash and backslash. Then a tiny routine rotates through them one by one. Okay, let's write the code for the user form now. Now let us take a look at the code. At the top, there are two private variables. Spinner frames holds the different characters that make up the spinner, basically the little frames of our animation. Current frame index keeps track of which frame we are showing right now. They are declared at the top, so every procedure inside this form can use them. When the form loads, the initialize procedure runs automatically. Here is what is happening inside it. This line is the key part. We are taking one long string and using the split function to break it into separate parts wherever there is a space. That gives us a small list of 4 characters, the vertical bar, the /, the dash and the backslash. These 4 characters act as frames of animation, and when we cycle through them quickly, it feels like the spinner is rotating. Next is the tick procedure, and this is where the animation actually moves. Each time tick runs, the spinner advances to the next frame. This line handles that logic. We simply add 1 to the current frame and the mod operator makes sure that when we reach the last frame, we loop back to the first one. So once we finish the 4th character, the counter goes back to 0 and the animation continues smoothly. After that, this line updates the label to show the new character. And me.repaint refreshes the user form right away, so the change appears instantly on the screen. So to summarize, initialize prepares the list of spinner characters and tick moves from one character to the next and refreshes the display. There is nothing complicated here. It is just a few simple keyboard characters switching quickly and Excel gives the illusion of movement. Before we test the spinner, we need a small procedure that will launch the form and keep the spinner active while Excel is working. I will add a new module now. Let's name it E_progress spinner. I will now quickly write the code inside this module. This procedure is called spinner progress. We begin by creating an instance of our user form FRM progress spinner. Just like before, it is shown in modeless mode, so the rest of the code can keep running. Next, we set up a simple timer. Start time holds the current value of timer, which is the system time in seconds. The loop runs until 10 seconds have passed. Think of this as a stand-in for whatever long task your macro normally performs, such as exporting several files, cleaning a large data set, or processing thousands of records. Inside the loop, the same 3 steps repeat over and over. The tick procedure updates the spinner to the next frame, which creates the rotating effect. This line adds a short delay so the animation is visible. And do events keeps Excel responsive and allows the screen to update smoothly. In a real macro, this is where your actual work would happen. Once the loop ends, the user form is unloaded and everything is cleaned up. That is all there is to it. It is simple and very effective. Let us run it and take a look. There it is. The spinner comes to life. Every fraction of a second, it cycles through the 4 characters, the vertical bar, the forward slash, the dash and the backslash. When they change quickly, it gives the illusion of rotation. This is a great little indicator for situations where you have no way of knowing how long a process will take. It simply shows that Excel is still working. And when the task finishes, the form closes automatically. It is quick, clean and gets out of the way. So that is the spinner progress indicator. It is light, minimal, and you can add it to any macro to make Excel feel far more responsive. The spinner is useful when the duration of a task is unknown. But sometimes you may want something more fun. A small character walking across the screen can be a playful way to show activity while Excel works. It still tells the user that something is happening, and it adds a bit of personality. In the next part, we will build a walking character progress bar. The form uses a few images that I have already exported for you, and the download link is in the description. So let's begin. Let's build the form step by step. First, I am inserting a new user form. I will rename it to FRM Progress Walk. Now I will make the form a little wider so everything fits nicely. In the properties window, I am setting the back color to white because all my sprite images have a white background. As usual, I am setting startup position to center screen so the form opens in the middle. Next, I will add a frame. This will act like the stage where our character will walk. I am naming this frame FRS stage. Let's also remove the caption so that we get a clean look for the frame. I will also resize it so it sits neatly on the form. I am leaving a little space at the bottom because we will put a progress label there. Now I will add an image control. This will hold the walking animation frame that keeps changing. Let's name this as IMG Sprite. I am placing it on the left side inside the frame, which will be the starting point. Let's leave a bit of padding so the sprite does not touch the edges. Change the back style to transparent. Set the border style to none. My images are small, so I am keeping picture size mode as clip. You can adjust this based on your own images. About the images, I already exported a small sequence of images like walk 1 JPG, walk 2 JPG, up to walk 6 JPG. Please download the zip from the description, extract it and use that folder path in the code. Next, I will add a small label. This will show messages like walking to the end or arrived. I will name it LBL MSG. Change the back style to transparent. Let's also resize the label so the text fits nicely at runtime. Finally, delete the caption so it starts empty. That's it for the design. The form is now ready. Now we will add the code that loads the images and moves the character across the stage. Right click on the form and select View Code. I will start writing the code now. Let's walk through this code slowly and see what each part is doing. At the top, we have a bunch of private variables. Stage padding controls how much empty space we keep inside the stage, so the sprite does not stick to the edges. Move direction tells us which way the character is moving. A value of 1 means move to the right, and a value of -1 would mean move to the left. Arrived at right is a flag that becomes true when the character reaches the right side of the stage. Total frame stores how many images we have in the walking cycle. Sprite frames is an array of pictures, one picture for each frame of the animation. Current frame index tracks which frame we are currently showing. Pixels per tick tells us how many pixels the character should move every time tick walk runs. Bounce at ends decides whether the character should bounce back when it hits the edge. Stop at right edge decides whether it should stop when it reaches the right side. Last yield time is used for timing so that we do not call do events too often. In UserForm initialize, we set up the starting state of the form. The message label shows starting so the user knows something is about to happen. The stage padding is set to 4, which gives us a small margin inside the frame. Move direction is set to 1, so the sprite starts moving to the right. Arrived at right is set to false because we have not reached the right edge yet. Now look at start walk. This procedure prepares everything for the walking animation. The parameters tell it where to find the images, how many frames there are, what prefix and extension the files use, and how the motion should behave. The folder parameter is the path where the images are stored. Count tells us how many frames there are. Prefix and ext help build the file names. For example, walk1 JPG, walk2 JPG, and so on. Px per tick sets how fast the sprite moves. Stop at right tells us if we stop at the right edge or not. Bounce says whether we should bounce back when we hit the edge. Inside start walk, we set total frames to the count. Then we resize the sprite frames array, so it has one slot for each frame. The for loop builds the full path for each image and loads it with load picture. If any picture fails to load, the code raises an error with a clear message that tells you which frame is missing or unsupported. Once all frames are loaded, current frame index is set to 1 and the first image is shown in img sprite. Next, we center the sprite vertically inside FRA stage by adjusting img sprite.top. Horizontally, we place it at the left side with img sprite.left equal to stage padding. Then we copy the motion settings into the internal variables. Pixels per tick is set from px per tick. Bounce at ends and stop at right edge are set from the corresponding parameters. Arrived at right is reset to false. Move direction is set to 1 again. So we always start moving to the right. Last yield time takes the current value of timer, which we use later to decide when to call do events. Finally, me.repaint makes sure the form draws the sprite in the correct starting position. Now look at tick walk. This procedure is called over and over again while the macro is running. If there are no frames loaded or we have already arrived at the right edge, the sub exits immediately. If we are still allowed to move, we first advance the animation frame. Current frame index is incremented by 1. If we go past total frames, we wrap around and go back to frame 1. Then img sprite.picture is updated to show the new frame, which gives the illusion of walking. Next, we calculate how far the sprite is allowed to move. Left bound is the left limit inside the stage, which is stage padding. Right bound is the right limit, which we calculate from the inner width of FRA stage minus the sprite width and the padding. New left is the new horizontal position we want to move to. It is the current left position plus move direction times pixels per tick. If new left is greater than or equal to the right bound, we clamp it to the right bound so it does not go out of the frame. Then we check how to behave at this edge. If bounce at ends is true, we reverse the move direction so the character starts moving back to the left. If neither of those options is active, we loop back to the left by setting new left to left bound. If new left is less than or equal to left bound, we clamp it to the left edge. If bounce at ends is true in this case, we change move direction back to 1. So the sprite goes to the right again. After all this logic, img sprite.left is updated to new left, which moves the character on the screen. Me.repaint refreshes the form so the new frame and position are visible. Then we check the timing. If enough time has passed since last yield time, we call do events. So Excel stays responsive and update last yield time to the current time. The arrived right property is meant to let the outside code check whether the sprite has reached the right side. It should return the internal flag that tracks that state. So the idea is that your calling code can say loop until arrived right is true and then stop animating. Finally, set message is a small helper that lets you update the label on the form. It assigns the text you pass into lblmsg.caption and repaints the form. So you can show messages like walking to the end or done while the character is moving. Now let's insert a module from where we will launch this form. We will name it f_progress walk. I will now write the code. This subroutine creates an instance of the walking progress form by declaring walk form as a new FRM progress walk. As usual, we show the form in modeless mode so the code can continue running while the animation plays. Next, the start walk procedure is called. This tells the form where the images are stored, how many frames there are, the file name pattern, the speed of movement, and how the animation should behave. In this example, this is the folder path. There are 6 frames, the prefix is walk, the extension is JPG. The movement speed is 4 pixels per tick, the animation should stop at the right edge and bouncing is turned off. After that, the message below the sprite is updated to say walking to the end. Now the loop begins. Inside this loop, tick walk is called to advance the animation by 1 frame and move the sprite a few pixels forward. Pause for seconds adds a short delay so the animation looks smooth and does not run too fast. Do events keeps Excel responsive and lets the screen update. The loop continues until the property arrived right becomes true. Once the sprite reaches the right edge, the loop ends. The message is then updated to say arrived. And here a 2-second pause gives the user time to see the final state. Finally, unload walk form closes the form and clears it from memory. So in short, this macro goes through 4 simple steps. It creates and shows the walking form. It starts the animation using the frame images we loaded. It keeps the sprite moving until it reaches the right edge. Then it displays arrived and closes the form. Time to test it now. Place the cursor inside the procedure and press the F5 key on your keyboard. It is a fun and friendly way to show progress, and the nice thing is that you can reuse the same macro anywhere by changing the image folder or the movement speed. It is clean, simple, and easy for users to understand. So this is your walking character progress bar. As a little bonus, I've also added 2 ready-made demo forms where you can see the progress bars in action. Each one shows a different style and you can open them up to inspect the code yourself. I've commented everything clearly so it's easy to understand, but if you still have any questions, just drop them in the comments. I'll be happy to help. Okay, let's check them out. Alright, let's test the first demo form. Right click on the FRM demo 1 and click View Object. I designed this form so that you can use when your macro has clear stages. This form takes the images from the image folder which is there in the zip file. The main image at the top keeps changing as the progress moves forward. Below that, you'll see 4 small icons that turn green when their step becomes active. You can also click the icons manually to jump to any step you want. The main image updates instantly when you click. This works really well for macros that will report step by step. For example, fetching data can show one image, cleaning data can show another, and preparing the layout can show the next. The yellow bar behind everything will keep growing while the macro runs. The user gets a visual preview of what is happening at every stage. To run this, open the module gdemo1. Run the procedure image progress. So instead of a plain bar, this gives you a more guided and more visual progress experience. It is especially useful when generating reports, exporting files, or creating dashboards where each stage produces a different output. Now let's check out the second demo form. Right click on the FRM demo 2 and click View Object. Here is another progress bar that looks clean, modern, and very smooth on screen. This one uses a circular ring that fills up as the macro runs. The percentage appears right in the center and the ring updates in real time. The interesting part is how this works behind the scenes. On sheet 3, there is a donut chart already set up. The chart is linked to a cell that holds a value between 0 and 1. As the macro runs, we update that cell with the current progress fraction. The moment the value changes, the chart redraws itself and shows the updated ring. Right after that, the chart is exported as a BMP file into the temp folder. The UserForm then loads that exported image into the image control called IMG circle. So every time the macro moves forward, sheet 3 updates, the chart redraws, the BMP is exported, and the UserForm shows the latest frame. This gives the illusion of a smooth circular animation even though it is simply showing updated chart snapshots. Let's run it. Open the module HDemo2. Run the procedure runtime circular progress. This style works really well when you want a polished professional progress indicator. It is perfect for any long-running task like building reports, processing data, exporting files, or consolidating sheets. The whole thing runs without any external images because the chart is generated live at runtime. And that's it. 6 different ways to show progress in your VBA projects. From a simple status bar update to a full walking character animation, you have seen how flexible VBA can be for user feedback. Remember, a good progress bar is not just about looks, it is about keeping users informed and confident that your macro is still running. This becomes really important when you are processing thousands of rows or exporting a lot of files. If you have any questions about what we covered, feel free to post them in the comments below. You can also email me at support@timexcel.com. I also have a VBA Facebook group. Feel free to post your question there. And if you do, then just ensure you attach a clear screenshot so it is easier to understand the problem. And hey, if this tutorial saved you time or taught you something useful, you can click the super thanks button below the video. It really helps support the channel and lets me keep making more tutorials like this. If you found this video helpful, hit like and subscribe to the channel. That way you will get notified as soon as the next video goes live. Thanks for watching, and remember, never let Excel freeze without style.